Hi, this is Lori, and welcome to my series on the Raspberry Pi Pico W. Today we're going to be building a binary clock with our Pico. This episode builds on the previous episode where we built a binary counter with the Pico. So if you need a refresher on binary numbers and how to hook up LEDs to the Pico, take a look at that video. I'll put the link in the description. If you're ready to go, let's make a binary clock. I got the idea to do a binary clock project from another YouTuber friend of mine, Big Bogey Face, or BBF. So thanks to him for this idea. There are two major versions of binary clocks that I've seen out there. One is called the pure binary, and the other I've been calling hybrid binary, or I've also seen it called binary coded decimal. And we'll talk first about the pure binary. There are 3 rows of LEDs on a pure binary clock. The first one represents the hours, second row is the minutes, third row is the seconds. So when we think about how many LEDs we're going to need to represent the numbers we need for telling time, we can see with 2 LEDs we'd be able to go up to the number 3. With 3 LEDs we'd get up to 7. 4 gets us to 15, 5 gets us to 31, and 6 gets us to 63. Going back and looking at the pure binary clock, we can see that there are 5 LEDs for hours, because if we're doing military time, we'll need to get up to 23. So 5 will get us up to 23. Then the minutes and seconds use 6 LEDs because we'll need to display a 59, and we'll need 6 LEDs to do that. Here's the layout for the hybrid binary. It's hybrid because it blends binary number thinking with decimal number thinking. Let's take a look. There are 3 sections, hours, minutes, and seconds, and then 2 columns, one to represent the first digit when we think about it as a decimal, and one to represent the second digit when we think about it as a decimal. So the ones place and the tens place. That's the decimal part of this clock. Then each of those digits, the tens place digit and the ones place digit, will be represented in binary. So we have the 1, 2, 4, and 8's place going up. Now if we think about hours, with the military clock, we'll need to be able to display up to 23. So for the tens place, we only need to display a 0, 1, or a 2, so only 2 LEDs are needed to display that digit. But when we get to the second digit of hours, we need to go from 0 to 9, so we'll need to be able to use 4 LEDs to display that. Looking at minutes and seconds, you can see that the tens place, now we need to be able to display up to 5 for 59. We'll need 3 LEDs to get up to 5. And then again for the second place, the ones place, we'll need to be able to get up to a 9, so we'll need those 4 LEDs to do that. A lot going on this slide. Let's focus over here on the actual circuit. So doing this on a breadboard is really a bit challenging, and I spent a fair amount of time just getting this set up and wired correctly. And I started to think that maybe this was a silly idea because of so many connections and resistors were needed to do it, but I really wanted to see if I could make it work. So this is the layout of the circuit, and I was really careful to use wires, and you'll see when you look at my actual circuit as well, I use these color wires to try to help me keep everything straight. So if you're going to try to do this on a breadboard, I definitely recommend that you really stick to some colors to help you do all the connections. And you'll have to debug this circuit. There's no doubt you'll probably put something in wrong. I certainly did and had to go back. So we'll actually have a program just to test the circuit out. And I run it every now and then because if I jiggle the circuit a little bit, sometimes some of the contacts get messed up. So that's how everything gets put together. It's just LEDs with current limiting resistors, and they come back to various GPIO pins on the Pico. And you can look at this diagram and slowly put it together. I happen to have a lot of 220 ohm resistors, so that's what I used in my circuit. But if you don't have enough 220s, you could certainly use 330s and maybe even 470s to get enough resistors to put this together. You'll also need a lot of LEDs to make this happen too, and it's really nice, of course, if they're all the same color for the seconds and the same color for the minutes and the same color for the hours, if you can do it. They are pretty cheap, and you can order extra from your favorite electronics store to make this project happen. Now I made the arrangement of mine up and down because making it side by side didn't really work in the way a breadboard is laid out, so that's why I did it this way. It's a little fun too to kind of switch it up a little bit. And you can see I put the hours at the top, the minutes next, and the seconds, and then this is the tens and ones place. And here I'm just showing, I'm doing a military time, so I'm going to be 24 hours rather than the typical one we would use in the US, where we go 0 through 11 and put an AM or PM on our time. And that's a choice you can make, and you can certainly do as a challenge to switch this around to be a 12-hour clock rather than a 24-hour clock. And here's an example of 13:45:29. So you can see, just have everything filled. We're showing a 1 for this digit, a 3 for this digit, a 4 for the minutes, and a 5, 45, 2, and then a 9. So it works pretty well. Recognizing it can be a little challenging though. I put together this slide just to help with the challenge of being able to see the time more quickly, and that's remembering that you have the 1s, 2s, 4s, and 8s place for your binary. And if you kind of imagine this as a math problem, you can kind of just sort of add up the numbers. So here I have 16, 27, 31, which would be 4:27 in the afternoon. If I add these up, this one's lit for the 1. I get a 1 there. And then we have to light to make the 6, the 2, and the 4. We add that up, it's a 6. So if you kind of imagine these numbers being on the lights, I think it can help you a little bit as you try to recognize the pattern to get the various numbers of minutes and seconds and hours. Taking a look at the actual circuit, you can see the hours at the top, the minutes in the middle as blue, and the seconds at the bottom in green. You'll also notice I used the jumper wires, kind of the loopy kind. I found that there were just a lot of wires to do, and making my own would take some time. And I was able to kind of be pretty neat, I think, with the loopy wires, so it worked for me. You can certainly do it any way you want. If you want to use the neater breadboard wires that you can put exactly to the right length, that would work too. Now on to the program that we use to check to see if the LEDs are all wired up correctly. We'll import the needed libraries, created a long tuple, which is kind of a listing of all the GPIO pins that I used. There's 20 of them. And then going to use that My LEDs tuple to loop through and turn them all into outputs without having to do it 20 times. And then in the while true loop, we'll use that same sort of trick to turn them all on and then to turn them all off. Let's give it a go. There we go. And they look like they're all flashing. Every one of them is working. That's excellent. Now onto the program that'll operate the binary clock. Again, we're doing a 24-hour rather than a 12. And to use this program, we'll have to have the Pico plugged into our computer through the USB cable, because that is where the Pico is going to get the actual time from. I plan on doing a future episode where we'll use the wireless part of our Pico to reach out into the internet and grab the current time and use that, and then the Pico could be independent of the computer. But for this time, we're going to use the computer to give us the time. Same as the check program, importing the same libraries. This time I decided to do all my setups separately, mainly because I wanted to be pretty neat and tidy with how I named all these pins, and make sure I named them things that I could remember what they were. So this was my choice, not to kind of do some kind of looping thing that I did in the check LED. And certainly this could be done more efficiently, but I did this because it felt neater and tidier to me. So I'll set up all the hour pins, and you can see setting all those up. Then here are the minute pins, and they're the ones in blue, and the seconds pins in green. We'll set all those up. Just sleep for a couple of seconds just to let everything get going, and then we'll go into our while true loop. Still using the try and accept so that we can use the Control-C to gracefully exit from the program. And when we do that, you can see when we exit using the Control-C, that's the keyboard interrupt, we'll turn all of our LEDs off. So big long listing of the 20 LEDs there. Let's get to the meat of this program in the while true loop. The first thing we'll need is to grab the time from the computer. We'll use the local time function for that. That will return us an 8 tuple, and it is in this order. The numbers are provided in this order. We need the hours, minutes, and seconds. So first I'll grab the hours from current time. So that's in the third spot, 0, 1, 2, 3. And then if the hours are less than 10, I know the first digit of hours will be a 0, and the second digit will be the hours, because that'll either be a 0 through a 9. If it's 10 or greater, then we'll need 2 digits, and we'll need to separate those. So we'll take the hours, we'll turn it into a string so we can get each digit individually, and then I take those digits, turn them back into integers, because we're going to use them further in the program as a number. Now we have the 2 digits for hours. Next we'll take the first hour digit, and we'll use the format function that I used in the binary counter to turn that decimal digit into a binary number. It's going to have 2 places, and we will separate those out by taking the binary number, which is now zeros and ones, and we'll pull the first spot and put that in the seconds place, and we'll pull the second spot and put that in the firsts place for binary. That will turn on or off the appropriate LED to display the binary version of the hour 1 digit. We'll do the same kind of thing for the second hour digit, but now we need 4 places in our binary number. We'll do that format change, and so now we have the second digit as binary. We'll again separate the 4 digits and assign them to the appropriate LED to turn it on or off. And that gets us through the hours. We'll do the same kind of thing for minutes and for seconds. We'll sleep just a little bit, and we're ready to go. Let's give it a run. So it should start. There we go. And we can see that the seconds are starting to count. So up here on the computer, I see that it's 1:48 in the afternoon. So that's a 13 for hours, and a 48 for the minutes. And the seconds are going to keep counting, obviously. And you can kind of watch them. You can see them moving forward and following the time. Pretty cool. So it seems to be working pretty good. And I think this is such a fun project that I plan on putting it down on a proto board to permanently keep it going. You'll also see it switch to 49, and it looks like the minutes are correct as well. Awesome. So stay tuned. I'll probably put that together as a video as well. and you can watch me struggle with soldering as I usually do. But I want to thank you for joining me.